later on in the course. So here I have, again, a small case of a simple lug, which is loaded. In this case, it's loaded in tension. And I mentioned the failure modes earlier, so I repeat them now. You can fail by breaking on either side of the hole, and that's the net section failure. It's a tension failure. You can fail by bearing, which means that this hole in the center will elongate, and eventually, you see how much it has elongated here, and eventually you will fail now in tension in that case. Or you have a combined net tension and shear out. You can see the failure here, where the shear stresses locally are too high and exceed the shear strength. And as if all this, again, were not enough, and it's hard to see here, there's a big delamination, and you will see a similar case on the part that I'm going to pass around. This one was not loaded in the longitudinal direction, it was loaded in the transverse direction. But if you look at it closely, you'll see most of the failure modes. You will see that the hole has elongated in one of the two directions, which means there's a bearing failure in that direction. You'll see that the material has moved out of the way. You have local compression failure. And you will see, if you look at it on the edge, basically a huge delamination where the layers have separated. And by the time it goes all the way around, we will have a vote on what is the load to failure this. And the units we will use will be fully grown female elephants. The reason we're using this and not cars is because previous years I was using cars, so some people are catching up with the correct answer. So now, as this goes around and you see the failure, try to think how many elephants, female, because they are significantly lighter than male, it would take. So we are trying to define the parameters of the problem correctly. Sandwich, I mentioned it briefly. Here it is again. Here is a failed sandwich structure in compression. So these are the loading tabs going into the test machine, and you will see that it actually buckled. And buckling means there's a tension side and a compression side, and the point A here is the highest compression, which means you can fail the constituents such as the face sheet or the core or the adhesive in compression. At point B, you have the maximum shear, so you can fail the adhesive in shear or the core in shear. You don't often fail the face sheet in shear, but you could. And then, of course, the overall, what is wrong with this? The overall buckling, you can see it has buckled. And then you can have failure modes such as the wrinkling, which is a very localized buckling failure mode, and intracellular buckling, which is even more localized because it happens within cells, individual cells.